Let's see the topic optical instruments. So here, optical instrument is a device which constructed by suitable combinations of mirrors. So you can take it as mirrors, prisms, lenses, and all these combinations. And this basic use of the optical instrument is it assists the eye in viewing the object. Okay? Optical instruments is a combination of mirrors, prisms, and lenses so that it assists the eye in viewing the. And second one, the principle of working of optical instrument is the law of reflections and law of refractions. Law of reflection and law of refraction. And a common type of optical instruments you can take naturally as a projection elements. So projection instruments will create a inverted, real inverted magnified images on on screen. So, example point of view, you are seeing a projections in the cinema theaters and any other real images from screens. And microscopes and all we are used to see very small objects. So very small objects are seen by microscopes and telescopes and all used to see astronomical objects. Astronomical objects. So, with the help of astronomical objects are seen by telescopes. So, majorly you can take as three different types of optical instruments. One is the projection instruments. Second one is the microscopes. Third one is the telescopes. Projection instruments are used to see the real and inverted magnified images on the optical materials, means on the screens. Microscopes are used to see very small objects by the microscopes, and the telescopes are used to see heavenly objects, means the object is very far from the eye. To see such type of objects we are using a telescopes. So before going to discuss about the optical instruments we need to know about the angle, visual angle. So here visual angle is nothing but the angle formed at the eye, the angle formed at the eye at the eye by the ray of light, by the ray of light coming from extreme points of an object, coming from extreme ends of an object, extreme ends of an object. You can take next as visual angle. See here, it is the object. Let us you can take in O dash be the object. So this O dash makes an angle at the eye. So if you take in for this one, it is theta 2. And here for this one, image will be created on the retina. So this part of the eye you can take as the retina. So the length of the image formed on the retina is given by the size of the image perceived by the eye. Therefore, if the visual angle is more and the angle is more here, the visual angle is more and the image perceived by the eye is more, and visual angle is lesser, image perceived by the eye is lesser. Now here you can see this location is theta 1. So definitely theta 1 here it is greater compared with the theta 2. Means angle subtended by the extreme ends of an object of the eye at this location. Let us you can take as it is your first location and it is your second location. At the first location, visual angle subtended here it is theta 1. When object is moves far away from the eye, then visual angle subtended by the eye or object at the eye you can take in space theta 2. In the first case, the length of the image formed on the retina you can take as I1, then length of the image formed on the retina you can take as second case I2. So if visual angle at the first case is greater compared with the second one, so hence Hence, image perceived by the eye in the first case is greater compared with image perceived by the eye in the second case. If visual angle is greater, then image perceived by the eye is also, the size of image perceived by the eye is also greater. So some points I mentioned here for better understand. The size of object, the size of object as perceived by the eye depends on the size of image formed at the retina. And next point, the size of image formed at the retina is roughly proportional to the size of image. Let us say, for example, eye is the size of image. So the size of image formed at the retina is roughly proportional to angle subtended by the object, that is a visual angle. Okay. Next, optical instruments are used to increase. So major point for the optical instruments, just it increases the visual angles artificially to increase the size of image formed on the retina. So basic theme of optical instruments is increase the visual angle artificially so as to increase the size of an image formed on the retina. And last point is, so when we view an object with an naked eye, the object must be placed somewhere between the infinity and the near point. For any objects, there is a one fixed distance is there to see the image clearly, clearly and comfortably. The distance you can take as we as least distance of distant vision. So least distance of distinct vision. So it will be depends on the age of a person and it will be depends upon the uh, optical nerves. So here basically I'm given a least distance of distant vision for normal persons, least distance of distance vision for normal adult. So for normal adult, you can take as a capital T, it is order of 25 centimeters. So if you take it for kids na or children's, it may be around 10 centimeters to 5 centimeters, 10 centimeters to 5 centimeters. But if you take in old age peoples, so old age people least distant of distance vision, you can go with the 1 meter or above 1 meter also we need to get. So this is the basic concept, basic information about the least distant of distant vision. So whenever object will be placed at a least distant of distant vision, the eye is see the object with comfortably and relaxed position. In this case, if you are placed the object of height is h, and the object as seen by the eye, so you can take a space with the visual angle theta naught. It is the maximum angle to see the object comfortably by the eye. Therefore, theta naught, the visual angle subtended by the object when the object kept at least distant of distant vision is the maximum angle subtended on the object or subtended by the object at the eye. That is, you can take next to as a theta naught that equal to, so height of the object divided by least distant of distant vision. So just you can use this triangle. So apply tan theta. So why? Because theta naught is very small compared with values high. Theta naught is very small compared up with cap small h divided by capital H. Therefore, directly you can apply the tan theta principles that equal to theta. Therefore, theta not equal to height of the object divided by least distance of distant vision for the normal person. So it is the maximum angle to see the image comfortably by the eyes. Next, you can see magnifying powers and angular magnification denotes with the capital M. So for telescope it is different and for microscopes it is different. For telescopes is visual angle subtended by the final image at the eye divided by visual angle subtended by the object at eye when seen by the naked eye. So means that is whenever you can place the object at least distant of distant vision. And here also see microscope magnification, visual angle subtended by the final image at the eye divided by visual angle subtended by the object at the eye when kept at least distant of distant vision. And here I am given some note points for this one. The term linear magnification is different from the magnifying power. So already we know that the linear magnification. So linear magnification is just nothing but size of image divided by size of object. Size of image divided by size of object. Whether if you take it is a perpendicular to principal axis or parallel to principal axis. You got uh, linear magnifications. But magnifying power gives Visual angle subtended by the final image to the visual angle subtended by the object when it is kept at a least distant of distant vision. Both are different cases, but both will gives the characteristics of image. Now, second point, linear magnification is already given. That is height of image by height of object. That is plus or minus v divided by u. Ratio of objects of the image to the height of object. Magnifying power is the ratio of apparent increasing in size of the image seen by the eye. While a later magnification, that is linear magnification, is a unitless. Why? Because both are same quantities. And capital M is the unit of capital M is x. That is how many times is greater compared with the size of object. So magnifying power is power of a microscope is 11. Then we can write as 11 into x. So where x is how many times the size of image will be greater compared with the size of the object. Okay. Next you can see now see the simple microscope or magnifying glass. So simple microscope is just nothing but a convex lens of short focal length can be used to see magnified images of small objects and is called as a magnifying glasses or simple microscope. When a small object is placed between optical center and the focus of a convex lens, its visual erect magnified image is formed on the same side of the lens, and the lens is held close to the eye, and the distance of the object is adjusted. So here we need to remember one point: the distance of object is adjusted, means objective lens will be adjusted in case of microscope. Objective lens, keep in mind, objective lens will be adjusted in case of microscopes. So till the image formed at the least distance of distant vision for the eye. Okay, the basic principle in the simple microscope is whenever object will be placed in between focus and optic center. So whenever object will be placed in between optic center and focus, a visual and erect and magnified image will be formed on the same side of the lens. That will seen by the eye. Okay. See, here I'm given two different cases. When the image formed at a least distant of distant vision, near point, or you can take a near point adjustment or strained view. So here I'm taken one object. So let us you can take an object A, B. It is placed in between optic center and focus. Then its image will be formed in the same side of the object at a distance A dash and B dash. Now we need to calculate magnifying power of microscope when the final image formed at least distant of distant vision. So in this case, magnifying power I'm taking M equal to MD. Why? Because final image formed at least distant of distant vision. So in this case, the formula for linear magnification, visual angle subtended by image, visual angle subtended by visual angle subtended by final image, final image divided by visual angle subtended by object, visual angle subtended by object when kept at capital D, least distance of distant vision. Now here you can see visual angle subtended by final image is nothing but see it is A dash B dash your final image and it is subtend the image you can take it as B as a beta divided by visual angle subtended by the final object when it is kept at least distant of distant vision. That is you can take it as B as alpha. From the diagram beta you can take it as B as beta is nothing but A dash B dash or you can take in beta from this equation AB divided by OA. So beta is nothing but AB divided by AC into 1 upon alpha is nothing but. So for alpha opposite is A dash Q. So A dash Q divided by so A dash C. So AB is nothing but height of the object divided by AC is nothing but object distance taken as V as U and A dash C is the image distance you can take as V as a V divided by A dash Q is the height of the object you can take as V as H. both h and h get cancelled. You got v divided by u. So you got v divided by u. How we need to calculate a v and how we need to calculate u? Now we need to think. So where v simply you can take as v as minus d, and u we need to find out. So that value we need to get from the lens formula. See here, you taken as to be as unknown value, no known unknown value for you, but final image will be formed at minus d. Focal length of convex lens if you take as to be as a f now. So focal length of convex lens if you take as to be as f. Okay. Now here you can see u value is also having a negative sign. So that is you can take it as to as a minus u. V value equal to minus d, and focal length we need to take as to as a positive. Why? Because it is a convex. Therefore, substituted these values in lens formula 1 by v minus 1 by u equal to 1 by f. Therefore, 1 by v is nothing but a minus d, minus 1 by u is nothing but a minus u, that equal to 1 by f. So I want 1 by v. Therefore, 1 by v equal to 1 by f plus 1 by d. So 1 by u, sorry, 1 by u equal to 1 by f plus 1 by d. So here you can substitute that one. So you got minus. So here minus u is also you can take as a minus, and minus minus get cancelled. Therefore, d divided by u. So d times of 1 by u is nothing but, so 1 by f plus 1 by d. So you got multiply with that one 1 plus capital D divided by f. That is your magnifying power of microscope whenever final image formed at least distant of distant vision. See in the second case, when the image formed at the infinity. So here also you can take in magnifying power is, so magnifying power of a microscope you can take as v as m, that equal to whenever final image formed at infinity you can take as v as infinity. So here magnifying power of microscope whenever final image formed at infinity na, visual angle separated by final image at the eye you can take as v as a beta. In the diagram, visual angle separated by the I is beta divided by visual angle separated by the object when it is kept at a linear least distant of distant vision. Now you can see the beta value. For the beta, tans you can apply na f dash times of b. So f dash times of b divided by, so c times of f dash. C times of f dash. Alpha is nothing but na 1 upon alpha is c times of alpha is a dash b dash. So a dash b dash times of adjacent you can take in a dash times of c. So f dash b is nothing but height of the object you can take as v as a h naught. And c f dash is focal length of the lens you can take as v as a minus f. Why? Because light rays will be moved in this direction. We need to calculate to opposite direction into f dash a dash c is nothing but the least distant of distant vision. That is also you can take as v as a minus d divided by a dash b dash is the height of an object. You can take as v as h naught. So therefore here minus and here minus get cancelled. H naught get cancelled. Linear magnification, that is magnifying power of simple microscope whenever image formed at infinity na. So you can take in least distant of distant vision times of focal length of a lens. That is linear magnifying power of simple microscope whenever final image forms at infinity. And see, first case, whenever final image will be forms at least distant of distant vision, na, so your magnifying power is 1 plus d divided by f. Whenever final image formed at infinity, na, you got magnifying power is d divided by f.